Hello everybody and welcome to another mystery box function challenge. In the purple mystery box there is some math and your challenge is to figure out what it is. It's the last week of our year-long series, so every day is a special challenge day. So this math inside the purple box is going to be particularly challenging today. If you'd like to try it out on your own, you can use the link in the description, and when you've got an idea, come on back and see if we get the same thing. All right, let's start with a 0. Okay, 0, 0. How about a 1? 1 gives us 2. How about a 2? 2 gives us 6. How about a 3? And we're off the graph at 12. I'm going to go one more so we have numbers to work with. That's 20. Let's look in the negatives then. So we're getting some symmetry here. Let's see if that continues. Looks like it does, and I'm just going to put in a -3, see if we're going to get the 12. All right, so at first glance, I think this looks pretty much like a quadratic, and maybe with a little bit of a multiplier on it. One way, we haven't done this very often, one way to analyze whether something is a quadratic is to look at the difference between each step. So that's why I did these steps here. So we have a difference of 2, and then a difference of 4, and then a difference of 6. So that's our first order difference. If we get the same, if it's the same number in our first order differences, we know it's a linear equation. If it's the same number in our second order difference, so we take the difference of the differences, and in this case 2 and between 2 and 4 is 2, and 4 and 6 is 2. Now we're getting the same number. That when the second order difference is the same, that means it's a quadratic. So I think we've got a quadratic going on. It's a little odd though. It's a little odd. So it's not, so normally I would look here and I would say this is obviously 2 times x squared. And if you put in 1, you're going to get 2. If you put in 2, you should get 8, and we are not getting 8. Also, this number, when it's a 2, means that the multiplier on your quadratic is just 1. So that's not what's going on here. So something must be being added to this. Let's get some values closer to 0. I'm very curious about this shape now. Let's see if it looks like your typical quadratic. So 1/2 and -1/2. And let's look at, it's a little more V-shaped than I would have expected. Let's look at 1/4. And -1/4. Yeah, so you can see that in a quadratic, we would expect it to be kind of flattening near the bottom, but it stays pretty sharp here. It looks like the point of a pen maybe, or something like that. In fact, it's reminiscent a little bit of an absolute value function that comes to that sharp V. So it's somewhere between quadratic and absolute value. So how are those being combined? I mean, usually they aren't combined in any meaningful way, because what absolute value does is make everything positive. So does squaring something. Oh, well, what if we're just adding that? Does that? Well, that would make sense at 1, right? Because 1 squared plus the absolute value of 1, that would be 2. How about at 2? So 2 squared plus the absolute value of 2. Yeah, so that would be 4 plus 2 is 6. How about at 3? So 3 squared plus absolute value of 3. Yeah, and that's going to be 9. And it's not just x squared plus x, because in that one, if we put in, let's say, a -3 squared plus a -3, that's going to be 9 minus 3, or 6. But we're getting 9 plus 3 when we put in a 3 and getting 12. So I think that's got to be at x squared plus the absolute value of x. Let's go ahead and see if we're right. Yep, x squared plus the absolute value of x. Interesting. And let's graph that as well. Yeah, so you get something that looks, well, like it's halfway between that absolute value function and the quadratic. Well, how did that go for you? I think this was a bit of a head scratcher. Let me know. Thanks, everybody.